So this last lesson is going to focus on solving trig equations with identities and with some factoring. Okay, so this is the last lesson, so it's going to be the fanciest of all the lessons in solving. And here's some hints for you. When you are solving, okay, the angles must match. The angles must match, or the trig functions must match. And if they don't match, then you must be able to factor them apart and separate them. Okay, so we're going to look at some equations here where maybe there's identities or maybe there's factoring to solve it. So let's see. We're going to solve this equation in general. It's already equal to 0. This is the first term right here. All that stuff is multiplied together, and that's the second term. The good news is all the angles are matching. Except I can't add those like terms. It's not a quantity, it's not a product. So this is going to be a great time to factor. What is something that they both have? Remember, we don't change the angle here. Okay, we're not going to change the angle, but we are going to factor out cosine of 2x because they both have that. So cosine of 2x gets factored out. That leaves this first term as 2 times the sine of 2x plus 1 equals 0. If you like to put some parentheses around the angle, you can certainly do that. Okay, but in general here, we've got this first quantity times the second quantity. So we can use the zero product property. What we have here is the first thing, cosine of 2x must equal 0, or the second thing, 2 times the sine of 2x plus 1 equals 0. So this is the product property there, the zero product property where we separate them. Okay, minute unit circle time. Where is the cosine 0? Remember, we're not going to divide by 2. That's the angle. That's his name. You don't change his name. We're trying to figure out where the cosine is 0, and that happens up at pi over 2. And at 3 pi over 2. There's 2 places. Can you write this as one equation? Great, let's do it. The name of the angle is 2x. So 2x equals, one of the places is pi over 2 plus or minus pi n. Let's divide each and everything by 2. So x is going to be pi over 4 plus or minus pi over 2n. All right, let's go look at the second equation here. I could subtract 1 and divide by 2. So sine of 2x equals negative 1/2. So we've kind of done solving by arranging. We've already done when the name of the angle is 2 or 3 or half. So we're kind of putting that all together. Where is the sine negative 1/2? 2 places. One of them is in quadrant 3 at 7 pi over 6. And the next place is 11 pi over 6. Okay, I think we're going to have to write these equations as 2 separates. So let's do the 7 pi over 6 first. The name of the angle here is 2x. So 2x is at 7 pi over 6 plus or minus, we'll have to travel a full circle, 2 pi n. Let's divide all of them by 2. So x equals 7 pi over 12 plus or minus pi n. All right, now let's make the other equation for 11 pi over 6. The name of the angle is 2x. 11 pi over 6 plus or minus, we'll travel a full circle, 2 pi n, and let's divide them all by 2. That makes 11 pi over 12 plus or minus pi n. So those are the 3 equations you'd want to put on an answer line on a test. All right, let's take a look at this next equation here. When it says solve in the interval, that means we're going to have to make a chart. Okay. The first thing I notice is the angles are the same. That's good. Except I can't add a 1 This is something squared minus cosine minus 1. This is a trinomial. This is a quadratic equation. It's kind of like 2a squared minus a minus 1. Now, I know we practiced factoring, identities, and stuff last chapter, and that was to get us ready for this. So this would factor in terms of a's, like 2a and a. And I know it has to be a positive 1 and a negative 1. Let's put the negative here, and the positive here. Okay, except it wasn't a's, it was cosine of 2 theta. So how does this factor? 2, and it's cosine of 2 theta plus 1. And that thing again that we were making AB is cosine of 2 theta minus 1. And this equals to 0. So now we can do the zero product property. So either cosine of 2 theta equals minus 1 negative 1/2, or cosine of 2 theta equals 1. Okay, mini unit circle time. Where is cosine negative 1/2? And where is cosine of positive 1? Cosine is positive 1 right here. And I believe that's the only place. Where is cosine negative 1/2? Negative in quadrants 2 and 3 at 2 pi over 3 and 4 pi over 3. Okay, now it says in the interval, so that means we're going to have to make a chart. So we're going to make separate equations for all of these. Let's do this one first. This one looks easy. The name of the angle is 2 theta. And where does that angle equal 1? Right there at 0. Plus or minus, full circle, 2 pi n. Now, do we make the chart first or divide by 2 first? Let's divide by 2. Theta equals 0 plus or minus pi n. So let's make the chart. When n is 0, our first answer is 0. When n is 1, we're going to get pi. Can I add on another pi? Or will that be too much? 2 pi you cannot include, so that would be too much. All right, let's go make some equations and charts for these guys. I'm going to go way up here. The name of the angle is 2 theta. So 2 theta is at 2 pi over 3 plus or minus. We're going to have to do them separate. So a full circle, 2 pi n. Divide by 2. Theta is, cancel the 2's. 2 over 6 would be pi over 3 plus or minus pi n. And then, I guess we'll have to go down here. 2 theta equals 4 pi over 3 plus or minus 2 pi n. Let's divide by 2, so that's going to be 2 pi over 3 plus or minus pi n. And we're going to have to squeeze in some charts here. So let's make the fractions nice and say 3 over 3. And then same thing here. We're going to have to make the charts be 3 over 3. Okay, when n equals 0, the first angle is pi over 3. When n equals 1, it's going to be 4 pi over 3. How much out of 3 is too much? 6. So can I afford 4 plus 3 more? No. All right, when n is 0, we get 2 pi over 3. Oh, it's getting tiny. When n is 1, 2 plus 3 is 5 pi over 3. And I don't think I can fit any more. All right, so let's put all of our answers in a solution set from smallest to greatest. So I'll start with 0. And in terms of threes, we've got 1 out of 3. And then this is 4 out of 3. Oh, here comes 2 out of 3. 2 out of 3 comes next. And then, oh, here's 3 out of 3. So we'll write pi. Then we got 4 pi over 3. And then we've got 5 pi over 3. Wow, that was cute. 6 pi out of 3 would be too much. Okay, let's do another one here. Solve the equation in general. All right, so that means we're making an equation only. Wow, there are a lot of terms here. Terms are separated by plus and minus signs. So this equation has 4 terms. So there's no way I'm just adding a 1 and solving. I'm going to have to do some factoring. They're all sine of a regular x. Okay. How do you factor something that has 4 terms? We're going to have to do factor by grouping. That's right. So we'll do factor by grouping. All right, so let's look at the first 2. What can I take out of them? I can factor out sine squared. Sine squared of x. So the first group is going to have 2. You'll have 1 sine of x left over, and you have to say plus 1. If you distribute it back in, that makes sense. Now, looking at the next 2, they're both negative. And I know I want to make duplicates, so I'm going to take out a negative 1. You have to say plus or minus something here. That's going to make a positive 2 sine of x plus 1. Don't forget to say equals 0. This is an equation. Perfect. If they match, you can write this as the product of 2 quantities. One gets the things that you factored out, and one gets the duplicates. You only write that one time. Go ahead and check firsts, outers, inners, last. That should make that problem. Okay, the zero product property says we're now going to split these into 2. Some people say, should I use an identity and rearrange this? And I'd say be very careful of that, because if you make a mistake with identities, you're going to get everything wrong. We can just solve it like this, especially since I'm noticing that this would be negative cosine squared, and some people are going to fall for that. So if we solve this by hand, sine squared of x equals 1, or sine of x equals negative 1/2. Okay, over here we're not ready yet for unit circle. We're going to have to go ahead and square root. So the sine of x equals what, people? What? Did I hear you say plus or minus 1? I sure hope so. We've been doing that since the first chapter. So where, oh where, are these places? Sine is plus or minus 1 at pi over 2 and 3 pi over 2. Oh, that's going to be nice, one equation. Where is sine negative? Quadrants 3 and 4 at 7 pi over 6. And where else? 11 pi over 6. Okay, it looks like we're going to have 2 equations there. The nice thing is the name of the angle is just x. So my first equation, x equals pi over 2 plus or minus pi n. Okay, how about the next equation? Let's do the 7 pi over 6. The name of the angle is just x. X equals 7 pi over 6 plus or minus 2 pi n. And the last equation, x equals where? 11 pi over 6 plus or minus 2 pi n. You always state the angle as a positive angle. We only swing down when we're doing inverses and stuff. Okay, so this is how the solving gets to be a lot more fun. Let's take a look at some problems where there's identities. Okay, so always be on the lookout for identities. Here's an equation, okay, but it's not a zero product property. Some people think they can do the zero product property, but that would not be a good time to use that because it's not a zero. So let's see if we can approach this a different way. What if I were to multiply both sides by 2? Okay, that would make 2 times the sine of theta times the cosine of theta. And that equals negative 1. And now it's time for me to say, doesn't that look familiar? Doesn't this look familiar? I really hope it looks familiar. And if not, you're going to have to go back to your last identities page and find it. Go ahead, go back. Turn back. Hopefully you wrote them down yesterday. Go look at page 47. Yes, that's the sine of double angle 2 theta equals negative 1. Now that it's just one trig function, we can solve this. Where is the angle negative 1? Unit circle time. Where is sine negative 1? Oh, down here. Notice the name of the angle is 2 theta, so let's say 2 theta equals 3 pi over 2 plus or minus, it's going to have to be a full circle, 2 pi n. The name of the angle was 2 theta, so that means everybody has to get divided by 2. So that's 3 pi over 4 plus or minus pi n. Let's read the directions here. It says that they want all angles in the interval from 0 to 2 pi. So that means we have to make a chart. So let's go ahead and make a chart here. And I'm going to write pi as 4 over 4. So when n equals 0, we have 3 pi over 4. When n is 1, 3 plus 4 is 7 pi over 4. How much out of 4 would be too much? 8 out of 4. I think we're done. Our solution set is 3 pi over 4 and 7 pi over 4 in reduced form from smallest to greatest. Okay, let's take a look at this next one. So be on the lookout for identities. We solve it in general. That means we're going to make an equation. Let's see here. What can we do? We're trying to solve this. And the angles match. That's good news. I got a theta and a theta. Okay, so we could definitely solve this. What if we factor out a 3? That would be cosine of theta plus 1 equals 2 sine squared of theta. How are we going to solve this equation? Yeah, that's not going to work. Let's abort. Let's try another technique. Remember, we're looking at a square. This is a quadratic. Do you know how to solve quadratics? We're going to have to factor. What if we put everything on one side at least? So let's bring everybody, let's bring everyone to the left. 3 cosine of theta plus 3 minus 2 sine squared of theta. Okay, well at least it's all on the same side. But these are different. This is a cosine and that's a sine. These don't match. I really wish they matched. Well, let's go ahead and take one of them out and replace them. So we're going to have to use our identities. Do you know which one needs to be replaced? Well, the squared one, of course. Let's put parentheses around sine squared. And let's replace inside of those parentheses something that's equivalent to sine squared. How about 1 minus cosine squared? Hey, now they're all cosines. Cosine squared, a cosine, a number, that works. Should we do 3 minus 2? No, because that 2 here is getting multiplied. In fact, let's distribute in a negative 2. 3 cosine of theta plus 3. That's going to be minus 2. Distribute the negative plus 2 cosine squared theta equals 0. All right, let's put this in our favorite descending order. 2 cosine squared of theta plus 3 cosine theta plus 1 equals 0. Now we can definitely factor this. The angles are all the same, and all the terms are cosines. Okay, so we're going to factor this and make a 0. It's going to be 2 cosine of theta and a regular cosine of theta. I know that to make a 1, my lasts have to be 1s. Pluses or minuses in there? I think they're both going to get a plus. So this equation here, since this is 0, cosine of theta, negative 1/2. Where is cosine of theta, negative 1? Okay, let's go up here, make our little mini unit circles so we can think about this. Cosine is negative and quadrant 2 at 2 pi over 3. And cosine is negative at 4 pi over 3. Okay, and this is theta. Since it's in general, I can go ahead and write these equations together. I can write them together. Theta equals, if I was making a chart, I certainly wouldn't do this. But I could say, let's go up or down. So let's go plus or minus a distance of 2 pi over 3. After you decide to go up or down, and you're at one of those places, then you're going to travel a full circle, 2 pi n. Over here, where is cosine negative 1? Cosine is the x value, and he's negative 1 at pi. So the only angle we're going to have here, theta equals pi plus or minus 2 pi n. And we are done. Okay, the last one. Oh goodness, they all have cosines. That's good news. They all have the same trig function. They all match. Oh, except these angles don't match. So we certainly cannot put them together. We cannot put these together. Oh, how are we going to get those angles to match? I don't see any squares, so we're not going to be using the Pythagorean identities. We're going to have to work over here. That's a double angle. So if you go look at your identities for the double angles, we have a couple of choices. But let's choose wisely. Which double angle for cosine should we use? I know when we're calculating, I always recommended this one. Okay, but if I put cosine squareds and sine squareds into this problem, then I'll have things that don't match. So I kind of want it to match cosine. So which of these formulas would be the best? All right, let's use this one. 2 cosine squared. So 2 cosine squared. Okay, the double angle 2x says you make just a single x. So we have 2 theta. That's going to be just a regular theta minus 1. So there is the formula. Now let's write the rest of the problem too. We have plus 3 equals 5 cosine of theta. I'm noticing here we have a quadratic equation. And the best way to solve a quadratic equation is by moving it all to one side and factoring. So let's move everybody to the left. 2 cosine squared of theta minus 5 times cosine of theta plus 2 equals 0. You've made the 0 and you're quadratic. So let's go ahead and factor. 2 cosine of theta and a regular cosine of theta. I know that to make a 2, we got to put a 2 and a 1. 2 and a 1. Let's put the 2 here and the 1 here. That's going to work. 4 cosine, 1 cosine, except I need a negative 5. So which one gets negative? They're both going to get negative. Okay, we've got cosines, we got the same angle, equals to 0. We're ready to use the zero product property. Cosine of theta equals 1/2. Cosine of theta equals a 2. The directions here said solve in general. Okay, in general, we'll make equations and be done. Where's cosine 1/2? the unit circle here. He's positive in quadrant 1. Where? Pi over 3. And where else? Oh, down here at 5 pi over 3. Where is cosine 2? I know he's 1 right here. He's smaller than he's 0. Where's cosine 2? Yeah, nowhere. Cross that one up. Okay, so we're only going to get answers from this side. Since it says in general, I need to make an equation. Since they're equidistant up and down, I can actually write one equation. So I'm going to say, if you decide to go up or down, how much? Pi over 3 plus or minus pi over 3. After you decide to go up, then you're going to swing all the way back around to him, plus or minus 2 pi n. That is the only equation as the answer for this problem. Thank you.